Yesterday, we went over these rules of imaginary numbers. We figured out, or we learned that the square root of a negative number becomes imaginary. And we learned that cycle, I equals I, and then you go I squared, that ends up being a negative 1. Then I to the third really ends up being a negative I, and I to the fourth ends up being a positive 1. Okay. Now there's a mathematical explanation for all of these. And we've already explained that on the previous video on yesterday's post. So if you want to go back and understand, go back and watch yesterday's video. Anyways, we also solved some equations involving square roots, and we had to put a plus or minus in front of our answer. Is there any of these that you'd like to review before we move on to the last section of these notes? Any of them? Any of them? Going once? Going twice? Pick a question. Yeah, which one? Number 3, sure. So this guy right here, again, you're solving an equation. You want to get x by itself. That means you want to get rid of things. And how do you get rid of something? You do the opposite, the inverse operation. So you have negative 3 times x to the second power. You could easily get rid of the multiplication of negative 3 by dividing by negative 3, dividing by negative 3. That eliminates. You end up with x squared equals negative 8. And yes, we're going to apply a square root. And we do to one side, do to the other. The reason why I'm applying a square root is because a square root is the inverse operation of a square. It gets rid of it. So you will have a nice, beautiful x left over. However, we need to remember that when you apply a square root, you have to put a plus or minus in front of your answer, okay? Now the question is, what is the answer to the square root of negative 8? Well, I'm just going to show my work here, even though most of you already know how to do this. The negative sign is going to come out as an I, okay? But the actual work is saying, I'm going to rewrite negative 8 as negative 1 times 8. That way, when you split the root, everybody should recognize that the square root of negative 1 is I, right? So that's really an I right there. And the square root of 8, you could either do that on a calculator or you could do it by hand. 8's not a perfect square number, but I could rewrite it with multiplication to get a perfect square number like 4. And then when you split the root, you'll be able to do the square root of 4, which is 2, and the square root of 2 stays the square root of 2. So what do we have here? We really have I times 2 times the square root of 2. And the only thing you could do there is rearrange it in order. You put the number first, the variables next, and the radical at the very end. So there's your answer, x equals plus or minus 2i square root of 2. Sound good? Should we do another, or should we move on to the last section? Number 6, sure. Again, you want to get x by itself, okay? So we're going to get rid of the 14 first. You do the opposite of minus 14. So you go plus 14. What you do to one side, do to the other side. You end up with negative 4x squared equals, that is 13, okay? No, it's not. What am I saying, 13? My bad. Hold on a second. That is 23. So final step would be to divide by negative 4, divide by negative 4, and that will cancel out. You will end up with x squared equaling, now you can't really divide 23 by negative 4. However, we do need to get rid of that power of 2. So this is really a fraction, negative 23 over 4, and you want to get rid of that power of 2 by square rooting. Okay, now this is where it gets really interesting. So that's good that you guys asked this question. Yes, we have x by itself now. Yes, we have the equal sign. And yes, we're going to put a plus or minus in front of our answer. But this guy is what we need to work on. The square root of negative 23 over 4. The square root of negative 23 over 4. The quick and easy way of getting rid of a minus sign is just moving it out and it becomes an I. Okay, so what we really have is I with the square root of 23 over 4. Okay, now we all remember that you could split the square root if you're multiplying, and division is really the same thing as multiplication, right? So we could split the square root right here when we're dividing. So in other words, you're going to have I times, and you're going to have the square root of 23 over the square root of 4. And that works out nicely because the square root of 4 is 2. Okay, so that's really a 2. So what we really have here is I times the square root of 23 over 2. Now, That square root of 23, if you try it on a calculator, you can't simplify it. That it is what it is. So technically, you could write this divided by 2 as a fraction, right? So you could say that this divided by 2 is really a 1/2, and you could push that square root of 23 to the side, and you still have the multiplication of I. I know it's kind of confusing. I apologize. Anyways, 1/2 times I times square root of 23 is your final answer. So you're going to have x equals plus or minus 1/2 I square root of 23. Yesterday, we also learned that we simplify complex numbers. Complex numbers is just any binomial that has a real part and an imaginary part, okay? And we learned that we could simplify imaginary numbers the way we simplify expressions in algebra. So if you had like a 3x plus 2x, that would be a 5x. Same thing here, 3i plus 2i is a 5i. Same exact math as in Algebra 1. The only difference is that if you ever have a I squared, you know that I squared is really equal to -1. So whenever you have an I squared, you have to replace it with a -1 and then continue doing any math possible, okay? Is there any of these that you'd like to see me do again? We already did them yesterday, but is there anyone you would like to see right now real quick, just a refresher? Going once? What? 7. All right, let's take a look at 7. 7's a great one to start because it's actually a conjugate, and that's today's lesson, okay? We want to simplify this. It's just distributive property. You're going to distribute the multiplication of 3 first. 3 times 3 is 9. 3 times -2i is -6i. And then you're going to distribute the positive 2i. It's kind of like a positive 2x. If you had 2x times 3, that would be a 6x. In this case, it's just a positive 6i instead of a 6x. And at the very end, if you had a 2x times a -2x, that'd be a -4x squared. But in this case, it's a -4i squared. And that, when you hear I squared, that should ring a bell. That should remind you that I squared is really a -1, right? But before we actually switch that, look at the middle terms. That's a -6i and a positive 6i. When you combine them, they eliminate. So what we really have is a 9, and we have a -4 times -1, because that I squared is really a -1. -4 times -1 is positive 4. So 9 plus 4 is 13. And that worked out beautifully. Not because of coincidence, but because of us multiplying a binomial by its conjugate. Okay, you're probably thinking, what the heck's a conjugate? That's what we're learning today. Let's read it down here. The conjugate of a plus bi is a minus bi. Okay, so it's pretty much the identical binomial, but you just change the middle sign. Okay, so when you multiply a binomial with its conjugate, the imaginary terms disappear. When you combine the middle terms, they eliminate, and you end up with a nice, beautiful answer, like in this case, 13. Okay, so first we need to understand how to state the complex conjugate. Again, conjugate is simply the same binomial, and the binomials in this section have a real part and an imaginary part. So it's the same binomial, but all you got to do is change the sign of the middle term, or of the middle sign of the second term, right? So number 1, we have that complex number, the real part 3, the imaginary part -2i. So what would the complex conjugate be? Yep, 3 plus 2i. Are you kidding me? Yes, it's that easy. How about 5 plus I? What's a complex conjugate there? 5 minus I. Yep, that's ridiculous. How about the complex conjugate of -3 minus 7i? -3 plus 7i. Are you guys getting it? It's too easy. All you do is change that sign to a plus. Change that plus to a minus. Change that minus to a plus. Simple. Jordy, got it? So Jordy, if I tell you what's a complex conjugate of this, what are you going to say? -2 minus 6i instead of plus 6i, right? You change it to a minus 6i. It's that simple. So that is a complex conjugate. And when are we going to use a complex conjugate? Whenever you want to get rid of an imaginary term in an equation or in the denominator of a fraction, okay? Because here's the deal. You do not want imaginary numbers in the denominators, okay? You don't want this I down here. You don't want this I. You don't want any i's in the denominator, okay? So if you ever have a imaginary term or a complex number that has an imaginary value in there, all you have to do is you have to multiply both top and bottom by the denominators of the conjugate of the denominators. Right here it says the denominator's conjugate to get rid of both radicals and imaginary complex numbers. So number one, I do not want this I right here. Now we all know that I times I is what? I squared, which is what? -1. So if you have a single I down there, all you have to do is multiply by I, and then the I won't be there anymore. It'll become a -1. However, we can't do that here because we have a binomial. So first thing to do is to put that in parentheses, and then we're going to multiply both top and bottom by the conjugate of that complex number down there. So what's the conjugate? 1 minus 2i. Hopefully everybody's following along in their notes. And what you do to the bottom, you do to the top, 1 minus 2i. So this works out beautifully. Why? Because when I go 1 times 1, I get 1. 1 times -2i, I get -2i. I go positive 2i times 1, I'm going to get a positive 2i. And a positive 2i times a -2i, that's a -4i squared. Okay? Now, what happens with the middle terms? They eliminate. What happens with that I squared? That really becomes a -1. So the middle terms eliminate. I have 1, and I have -4 times -1. -4 times -1 is really a positive 4. So I end up with a 5. And that 5 is where? That 5 is in the denominator, because that's what I've done right here in the denominator. I got rid of the I changed it to a 5. But what I do to the bottom, I must do to the top. So up on top, I need to distribute 3 times 1. I want to get 3. 3 times -2i, I want to get -6i. And that is over that denominator 5. Okay? Now, keep in mind that on this section, we said complex numbers, they have two parts. It's a binomial. You want the real part first and the imaginary part second. So right here, you have something take away something in the numerator with the denominator of 5. So you could technically take that denominator of 5 and split them to each of them. Okay? It's kind of like this. If I said 10, okay, this has nothing to do with the problem. 10 plus 8 divided by 2. Well, what is 10 plus 8? 18. What's 18 divided by 2? 9. But I could easily take the 2 and put it on the 10. I could say 10 divided by 2 plus 8 divided by 2. And I would get the same answer, 9. Make sense? Okay, so we're going to take the denominator of 5 and split it. We're going to take the denominator of 5 and split it just for the sake of having a complex number organized, the real part first and the imaginary part second. So you're going to say 3 over 5, that's a real number, and then minus 6 over 5 with an I at the end. So this would be the appropriate best answer for number 1. And again, we do not want imaginary values in the denominator. And by the way, this is also true for square roots. You don't want to leave square roots in the denominator. So if you ever have a binomial with a square root, you multiply by its conjugate, and that'll also magically get rid of the square root term in the denominator. Let's do number 2. Okay, so we don't want that imaginary value in the denominator. I am going to multiply both top and bottom by what? 2 plus 4i. Excellent. 2 plus 4i. Okay, so on the bottom, 2 times 2 is 4. 2 times 4i is 8i. And then we distribute -4i times 2. That's a -8i. -4i times positive 4i. That'd be a -4 times 4 is 16. I times I is I squared, but we're going to change that to a -1 in a little bit. Look at the middle terms. They always cancel out when you do the binomial times its conjugate. They cancel out. Even if you didn't have i's, if it was just regular x's, like x plus 2 times x minus 2, the middle terms will cancel out. Okay. And what do we have left? We have a 4. We have a minus 16, but this is really minus 16 times -1, because I squared is really -1. So that's really going to be a plus 16. So we end up with what in the denominator? 20. Okay. I know it sounds like a lot of work, but it's really not. I mean, once you get used to it, it's not challenging. Let's distribute on the top. On the top, we have 5 times 2, that's 10. 5 times 4i, that's 20i. And to keep my answer or write my answer as best I can, we're going to separate the real part from the imaginary part. So I simply take that division of 20 and put it on the 10 and on the 20. Okay, so we're going to say 10 over 20 plus 20 over 20 with an I at the end. So reduce if possible. Of course, 10 over 20 reduces down to 1/2. 20 over 20 reduces down to 1. So you could just put I, or you could put 1I if you want. But that's your answer, 1/2 plus I. The real part's 1/2. The complex or the imaginary part is that 1I. You probably, hopefully, you're starting to understand this and it makes sense. That way you don't freak out, because this will be part of our next assessment that we have. I need to get rid of this I in the denominator, so I put parentheses around the whole thing. I'm going to multiply by the complex conjugate. What is that complex conjugate? -3 minus 2I. All you do is change the middle sign. Everything else stays the same. And of course, what you do to the bottom, you do the same identical thing to the top. Now, on the bottom, once you do this over and over and over, you're going to know that you're going to have a 9 plus 4, which would be 13. I just did that in my head because the middle terms are always going to cancel out. So I'm not going to show you any shortcuts. You'll develop those shortcuts on your own once you do them over and over and over. -3 times -3 is +9. -3 times -2i, +6i. +2i times -3, -6i. +2i times -2i is -4i squared. And like I said, the middle terms always cancel out. And you end up with a 9. And right here you have a -4 times a -1, because I squared is -1. So you really have a 9 plus 4. And 9 plus 4 is 13. Now, this problem's a little more challenging than the previous ones, because the previous ones only had one term up here in the numerator, and up here we have a binomial. So if we're going to multiply this binomial by that binomial, we have to distribute, put that first binomial in parentheses, and start distributing the way we did in the denominator. So I'm going to go 1 times -3, that's -3. 1 times -2i, that's -2i. And then I'm going to distribute +2i times -3, that's -6i. +2i times -2i, that's -4i squared. Now, right here, the middle terms do not cancel out. Why not? Because we didn't multiply by its conjugate. These are just regular two binomials. So I need to actually combine those. -2i minus 6i is -8i. Bring down the -3 in the front. The -4 times that I squared, that's really a -1. So -4 times -1, that's +4. And we could still combine the -3 with the +4, and we're going to get a +1. So the real part is +1. The imaginary part is -8i. Okay. Now that is the numerator, because here's the fraction. So we have the fraction bar. That's the numerator. And the denominator we said was 13. So there's our answer. We just need to separate it so it could be completely the real part first and the imaginary part second. So what's my final answer? Yeah, you could say 8i over 13. I'd rather just put 8 over 13 and then I after the fraction. Okay. And that is your answer for this question. Is this really going to be on the test? Yes, it is. I'm sorry. Last one. This one's actually easier than the rest because down here you do not have a binomial. I mean, you could say, well, the real part is 0, and then you could multiply by 0 plus 3i, right? But that's kind of a waste of time. There's an easier way of doing it. So let's not do that. The easier way of doing it is recognizing that there's only one term right here. It's -3 times I. And that I, if you were to multiply it by one more I, and of course what you do to the bottom, do to the top, but on top you have a binomial. Anyways, back to here. This I times one more I is going to be I squared, which means there's going to be no more I. It's going to be a -1, right? Because I squared is a -1. Yes or no? Yeah? So right here we have the -3, but instead of I squared, I'm going to put times -1 because I squared becomes -1. And that just becomes a +3. Does that make sense? Now up on top, I need to distribute I times 3. That's 3i. I times I, that's +I squared. And again, I squared becomes -1. So I really have a 3i minus 1. But let's put the real part first and the imaginary part second, which means that over here on my answer, where I have a fraction and a 3 in the denominator, we're going to have the -1 first and the positive 3i second. So here's our answer so far. We just need to split that denominator, and it'll become -1/3 plus 3/3 I. And of course, 3/3 I, that just eliminates and becomes 1. So it's -1/3 plus I. How does that taste? Good? I don't know. Okay. So this will be on the next assessment. I recommend going back and watching the video again so you get more comfortable with it. Maybe try doing it yourself on a separate sheet of paper. But this will be on the next quiz.